are both a measurement of weight. Just as you would have a conversion for these measurements, 1 calorie is equal to 4.18 kilojoules. If you want to change calories to kilojoules, you will multiply by 4.18, and if you wanted to convert kilojoules to calories, you would divide by 4.18. Energy is defined as the capacity to do work, and as we said in lesson 1, without food and water we would literally die. And one of the reasons for this is because without enough energy, our body cells literally don't have the energy to do our work, and their work is essentially to keep us alive. There are 4 calories or 17 kilojoules in 1 gram of both pure carbohydrates and protein, with fat containing more than double that at 9 calories or 37 kilojoules. Each and every one of us have different energy requirements. This is because your energy requirements depend on so many different factors like your age, gender, weight, height, level of physical activity, and your muscle mass. If you're pregnant or breastfeeding, your energy needs increase because you're growing a little person or producing milk. In people who are sick or injured, they might also need more energy to repair their bodies or fight infections. A person's body weight is one indicator of too much, enough, or too little energy. And we know that if you are in an energy deficit, that you will lose weight. What I want you guys to remember is that weight loss is due to an energy deficit and does not tell you anything about a person's health, their macronutrient or micronutrient status. So question time. Tell me guys, think back to the last few slides. How many kilojoules are in 1 calorie? Is it A, 1.48 kilojoules, B, 8.14 kilojoules, or C, 4.18 kilojoules? Okay, so think back. Is it A, B, or C? So how many kilojoules are in 1 calorie? I hope you guys got it right. It is C, 4.18 kilojoules in 1 calorie. Right, so what exactly are carbohydrates? Just like bricks build up to form a house, so sugars build up to form more complex starches. The most basic carbohydrate is called a monosaccharide. Mono means one. Examples of these include glucose, fructose, and a sugar called galactose. Disaccharides, di means two, are made up of 2 monosaccharides. For example, sucrose is made up of glucose and fructose. Other examples include lactose and maltose. Lastly, polysaccharides is made up of many sugars. Poly means many. Examples are the most commonly known: starch. So when a person talks about any carbohydrate containing food, it will contain 1 or more of these sugars. Monosaccharides are the shortest and most easily absorbed of the carbohydrates, and they don't need much digestion to be absorbed. Disaccharides need to be digested just a little bit, so a good example, like we said, is lactose, which is also known as milk sugar. And polysaccharides are the most complex sugars and need the most digestion. Often people refer to these as complex carbohydrates. I want you guys to imagine that you're a builder. If your boss asks you for a truckload of bricks, if you have a single brick, you can just kind of toss it onto the truck, so no extra steps are needed. If you had a wall in front of you, you would need to break down some of the plaster to get the individual bricks. And if you had a whole house in front of you, you would have to break down the walls, the doors, the windows, and the plaster. So this would need the most work in order to get it into the state that your body wants. So the carbohydrates are very similar in this regard, with the monosaccharides being the bricks, the disaccharides being the walls, and the polysaccharides being the entire house. So guys, remember, Tom is going to help us today to understand exactly how carbohydrates are digested. So once again, we are going to zoom into his GIT, which should look pretty familiar to you by now. We've learned that when we eat, our GIT digests the food into the smallest components possible. When we eat food that contain mainly carbohydrates, the smallest component is a monosaccharide like glucose. It is then absorbed mainly in the small intestine. Remember how the lining of the small intestine has a great surface area made up of microvilli and villi? Well, the sugars get absorbed through these structures and are then absorbed into your bloodstream. At this point, once it enters into your bloodstream, many medical professionals will refer to it as blood sugar. So, for example, when a diabetic tests their blood sugar, this is exactly what they're testing. The amount of sugar absorbed into the blood depends on the type and quantity of food that you've eaten, the combination of macronutrients, so carbs, proteins, and fats in your meals, and your individual biology and your health status, like your insulin sensitivity. The aim of digestion and absorption is to get the nutrients into your body cells. This is where they can be used for energy to keep you alive. The sugar in your blood triggers your pancreas to produce a very important hormone called insulin. There is constant feedback between your blood sugar levels and insulin levels. A healthy person's body will keep their blood sugar levels stable. So when there is more blood sugar, the pancreas will make more insulin. And when the blood sugar levels drop, the pancreas is told to stop making or decrease making insulin and helps to keep your levels as stable as possible. Insulin is a very important hormone, and if your body